And the code for the web service client was pretty limited. It's just a HTTP client and HTTP request, and on the get, we just set the get method, the URL, we execute it, and we send the response back to the user interface. And today we're going to expand on that. I'm going to expand the web service, the web module unit. In the web module unit, we had web action items, where I added a number action. And this is all going to be, this is all a bit fast. I mean, I'm going to slow down later on, so don't worry. And in the web action items, I added a web action number with a URL/number. And that's actually, in total, that's the URI, the Uniform Resource Identifier. And in that action, I returned a random number. Okay, so let's go back to the presentation. So we have today, we're going to add some more code, because just getting some data from your web service, a random number, well, that's nice, a web service, but it'll just get you a web service that you can use for a lottery. I just got confirmation that some other people can still see it as well, so it's still working. Screen and sound is okay. Okay, so the web broker key value boilerplate, what we will be creating today, we are going to expand the web service and add some put, post, and delete code in there, so you can actually add data to it instead of just getting data. We'll talk a little bit about the REST architecture, and we'll expand the client a bit as well. And that should make a functional web service that you could actually start using. So at the end of the day, you'll have a usable web service, which is kind of cool that you can do that in 2 hours. The storage for the data that we're going to put into the web service, that storage will be non-persistent, will be transient. That means that if you reset the web service, the storage will be gone. For that, we'll create an in-memory associative array. Kind of expensive words, but it's just a list of items, just a list of texts. And that list of texts is placed in a dictionary. And dictionary is a local in-memory storage that you can put key value pairs in. If you don't know what a key value pair is, just look that up in Wikipedia. A key value pair is a very useful concept. It allows you to load arbitrary data in this case, in a dictionary. So you could have a key with a name of a photo, and then the value could be the photo. Or you could have a key that has just the number 1, and then the value would be 1 written out. So you could have a word. And that's what we're doing here, by the way. The dictionary is quite efficient. It has order 1 search efficiency, and so it's very fast. And fast code is very relevant for your web service. The faster your web service code is, the more people you can actually service. Yesterday, I got a question about how many people can you service with this web service technology. That's about 1,000 per server. If you want to go up from there, you can use a web garden, or so you could service 10,000 even if you wanted to. But 1,000 is on one server should be fine, provided that it has a more than 1 CPU, so 4 CPUs, enough memory, stuff like that. And the T-dictionary actually helps because the T-dictionary is very fast in retrieving your data. How do you create such a dictionary? Well, let's just take a look and create that dictionary in Delphi. So we have the web service here and the web module unit, and we are going to create the dictionary in there. And that dictionary is just a bit of code we'll be using from system.generics collections. So we have to make sure that we have access to system.generics.collections. So I'm going to add system.generics.collections to the users clause in the implementation section. So here I'm going to add a users, and that users adds other units with other code to my existing project. So this is one of the ways to add existing code to your project. I'm going to use systems.generics.collections because that's the unit where the dictionary is declared in. I'm also going to add system.syncOBA because I'm going to need that later on. And I'm also going to add system.stringutils or some string utilities because I'm going to need that as well. System.generics.collections. It's telling me something's wrong here, so I'll just take a look. Could not compile used unit. Okay. Oh yeah, typo here. So just delete the S. Here you go. And that should work. Okay, so I'll just save that. I'm going to add a global variable with the dictionary of data. And that's a key value store. And it's a T dictionary. And that T dictionary going to hold a string value as a key and a string value as a value, like that. And that key value store currently it's telling me that it's declared but not used. That's correct. I haven't done anything with it yet. That key value store, I'm going to use the initialization section to actually create a globally initialized version of that. And then let's go J key, control space, key value store, just create the dictionary. And that's create. Just a typo again, just put a point there, that should work. Yeah. Okay, so just put a value in there as well. So we have a base value that we can return, just 0 and 0. Now, if you're typing along and I'm typing too fast, you can actually just open the completed version, which is just download it here. And on the source, web service part 2, and the web service server, you'll find a web model unit here as well. And if I open that with, let's say, Notepad, don't always use that, just use it once. You'll be able to see the code that I'm going to type in here as well. So you can just follow on, and if you're kind of lost, just go there and just copy it over. Or you can do this later on. I mean, that's fine as well. The complete instruction is actually in the handout. So the handout contains the complete instruction how to create this as well. So we now have an in-memory key value store. Now to retrieve a value in response of a HTTP request, we need to add a new GET request to the web service. And we did that yesterday as well. Let's just revisit how this GET works and go back to the slideshow. And then we'll create this GET request. So we now have in-memory storage, which is fine. And let's take a look at the HTTP commands that we're going to implement. We're going to do a GET, POST, PUT, and a delete. And the GET request in HTTP is used to retrieve whatever information is identified with the URI. Now we're using the GET for getting data. We'll be using the POST for updating data and the PUT for inserting data. It's like put in data, and delete for deleting data. But this is an arbitrary choice. That means it's just a choice that we made here because it's logical for our web service. But there are web services out there that do the reverse, actually. They use the POST to create an insert and use PUT to update and append. And that's perfectly fine as well, because both can be used. There are even web services that only use the GET to read and select, use POST to update, create, and insert, and use delete to delete, and they do not use PUT at all. And that's fine as well. So you've got some customization choices here. You can use the HTTP commands as you would like. there are some things that are default, so they're mostly used like that, but it's perfectly valid to do this another way. So because we're rolling our own web service, it doesn't really matter. And let's focus on the GET request, and let's skip this here. Now GET itself is idempotent and cached, and we'll get back to idempotency and cacheable later on. But first, let's take a look at the GET request. It could be cached, but the second or next request should yield the same value result. A request may return a not found error, and what it does, it's actually going to request a value from the dictionary. And what we need is a URL, which is HTTP localhost, and we need a uniform resource identifier, which will be /key value. I'm going to add that to the web service. So I'm going to add a /key value to the web service. So let's go to the web module unit, and in the web module unit, I will add a web action item. And I'm slowing down here to make sure that everyone's able to follow that. So in the web module actions, so go to web module, go to actions, click on the button there. In the web module actions, I'm going to add a new action. That web module action item is going to be a key value item. So I'm just going to add a key value get item. The path will be /key value. And the method will be a get method. You can see all the HTTP methods here: get, head, patch, post, put, and delete. Those are all supported in WebBroker. So just use get. Okay. In the on action, I'm going to send back a response. First, I'm going to just send back a default response with some information, just to check if this is working. Just put this there and just say, I don't know, message, yeah, it works. Okay, let's try that out. Just run this. Start it. And do a get request for key value, which I can do with the browser. And it works. It's actually JSON with a message with, yeah, it works. While we're at it, I'm going to introduce the REST debugger. I'll just keep this running. The REST debugger is an interesting tool that is bundled in Delphi. You can find that tool under Tools, REST debugger. The Community Edition, which is the Professional Edition, actually also has the REST debugger, so you should be able to find it there. Just start the REST debugger, and the REST debugger will allow you to debug your REST service. So let's just do a get here on HTTP localhost port 8080 key value and execute this get. And what we get is a body with valid JSON. Content is valid JSON, so this is okay. Actually, the headers are returned, application JSON, UTF-8, it all looks just fine. It's actually working, so that's good. You can also use your web service client that we created earlier to do the same. Setup number, just put in key value and get it. That works as well. Instead of returning this message, it's probably nicer to just return the data from the key value store. So let's write some code to actually get data from the key value store. In order to do that, we need to go a little further in the GET request. So the GET request, if we use that for a representational state transfer type web service, it'll need to know what I'm getting from the key value store, specifically the key in this case. So it needs to know that what the uniform resource identifier is, which is key value. and what key I want to get. So value 0. You can do that with URL segments like this with slashes. You can also do that with URL parameters, where you have a question mark key equals 0. I'm going to use URL segments here. URL segments are actually the default for REST services. So that's actually what's mostly used. I'm going to add that, and after I've added that, I'm going to go into the questions. So I'll go back into the questions panel and take a look at what the questions are. So I'm just going to add the get retrieve select with the key value /0 and support that in our web service. Stop it. Go back to Delphi. And the get action here was just this one here. I'm going to change that code. Now, instead of just typing it all out, I'm going to do a bit of cheating. I'll just use the existing source code that you have available as well. From the summer camp web services 2, source code web services part 2, in the server here. I'm going to open that with Notepad. I'm just going to copy the get code, which is just over here for the get action. Saves me a bit of typing, and I'll explain the source code, of course. Okay, so what are we doing here? T-string din array. Okay, so I need to add the users clause for T-string din array. And T-string din array is actually in system.types. So it should be there. Undeclared identifier. Maybe I'll just have to save it and just build it. So my code completion is getting a little confused. I'm not sure why. Oh, wait, I built the wrong one. So just build this one here. Yeah, now it is actually complaining about string din array. So it's not using system.types. So I'll just add system.types over here. And everything should be fine again. Okay. So what am I doing here? In the get action here, you'll get an initialization of the key, and I'll request the key from the query fields in the request. Now, you may not have this capability in the community edition. I'm not sure. So I'm just going to delete the query fields key stuff here, and I'll just use parameters like that. The parameters uses a get parameters function. That the get parameters function is actually parsing the URL and getting the segments out of that. And that's just a procedure that I wrote myself. It's not that complicated, actually, the procedure. I'll just copy it over. And put it in here. And this function, because it's Delphi uses Pascal. Pascal has a declaration as well as an implementation, and this is the implementation, that's the code. I'm going to put a declaration here as well. It's just a copy of the same function header. Like that. And then remove the web module 1. That should fix it. Okay, so what does get parameters do? Actually, when a end user requests a URL, let me see if I can just put it over there. That URL is going to look something like this. So that URL will look like this: HTTP localhost port 8080, the key value uniform resource identifier, and then a slash and a 0, slash and a 0 to actually request the value. This part, this is actually the action path. The action path that you have here in the web module action unit. If you go to web action items, the action path is actually HTTP localhost port 8080/key value. So this is the action path. The last part here, this is the URL segment that we need to determine the key. And that's what this thing is doing here. It's just using the action path and the full path of the request, and just using the end of the request path, so the right string of the request path, to get the parameter. And it's splitting that parameter with the slashes. So if you have multiple parameters, you'll get a list of parameters in a string din array, which is a dynamic array. And the first parameter will be the key. So that will be parameter 0. If you have a key, you set a response type and return the key value. Out of the box, this doesn't yet work. Why? Because if I'm using URL segment parameters in the web module action items, I actually have to expand the path. Otherwise, I'll just respond to /key value with nothing behind it. I have to make sure that the path info actually includes the star. So I respond to /key value /something. So, okay. Let's try this out. Let's see if that works. I start it, open the browser, go to key value, and request 0. And that works. So that's a raw data result 0. And the formatting here, that's JSON, and we'll get back to JSON at a later point in time. You may find this weirdly disconcerting because there's a 0 here and there's a 0 there. And if I add a value with 1, this will be 1 and 1. And what's this 0 doing here? Well, that's because I'm returning it as a array, which is a nice way of returning multiple values. So I have the option of returning multiple values, but only returning 1 here. Okay, so this works. It's nice. And we're about halfway, so I'll just look at the questions for a bit. And let's see here. All great. You might need to reconnect. Where can I find the handout? The handout's actually in the blog, in the webinar window itself. Are web services available in the 10.3 community edition? Yes, they are. So you should probably download the 10.4.2 that's just come out. But web broker, the basic web broker, is actually available in there. So yes, they are. And let's send that. I can actually show you that it's available. So you can download the, let me see here, go there, and then go to doc, and I have the Red Studio feature matrix. This is for 10.4.2, and if you go to web broker and DataSnet multi-tier, you'll see that there are a lot of features for DataSnet and web broker, but only the web broker bit here, that's what we're doing today, is actually supported in community edition. So that's supported. So that should work. If it doesn't, please let me know. Sometimes the installer messes up and it doesn't include everything. So you could use the ISO install if you want to. That's the offline installer. That's more reliable. If your internet connection just craps out and halfway, the installer doesn't always see that. Okay. So we have the GET request in our server. Now we need to continue and put the GET request in our client as well. But before we do that, we could continue with the put or the post. So we could do either. I mean, the GET request is already there. Let's just take a look at the code here. Web service client, web module unit. It's using response content to get it. Yeah, let's just go with the put in the post so I can add the data as well, because just getting data is not the intention of this session here. We need to put in post data as well. Okay, so a bit about the representational state transfer. We're using a web service, and that web service will implement the representational state transfer protocol. That all sounds complicated, but it really isn't, because the representational state transfer protocol only defines 4 actions. That is to receive, retrieve, insert, update, or delete a resource. That could be a document or a data element or just a key value. So the idea of REST, the basic idea is to be able to retrieve data, insert data, update data, and delete data. That's it. And that's mostly implemented in web services with HTTP. But you could also do that with other protocols, like SMTP for email, or FTP, file transfer protocol, or any other protocol that supports these 4 commands. But because HTTP actually has 4 commands, which are get, post, put, and delete, it's easy to actually do this with HTTP. The representational state transfer is pretty loosely defined. There's no solid definition, so there are many interpretations. You'll find many different variations of the representational state transfer protocol. Is that bad? No, it isn't, because it's so simple to use. It will actually just become a second nature to you. If you've seen a couple, you've seen them all. That's basically it. And they're easy to code and easy to maintain. Let's take a look at the HTTP post, because we have, let me see here, get, post, put, and delete. And we're going to map those to representational state transfer stuff. So the post, we're going to add, and we're going to use update. Again, there are also web services that use post for insert. There's a reason for that with the idempotency. We'll get into that later on. But in our web service, we're going to use post for update. And that post will be implemented with URL segments, as well as with the HTTP body. With URL segments, you can post a key value with key 1 and value 1. Accidentally clicked it. So the value is 1 here, and this is the key. Or you can use the HTTP body. So you have the URL, the URI, which is key value, the 1, which is the unique identifier for the key, and then a body content of 1. Why would you want to communicate using the HTTP body? The HTTP body allows you to send larger chunks of data that are also much more complicated. If you want to send data on a URL segment, you're quite limited. One of the obvious limitations is that you cannot use a semicolon or a slash, because that would mess your URL segment up. But there are other limitations as well. So sending it with the body is actually preferred. But you can send with URL segments as well. So I'm going to add this one here to the web service. Just go here to the web model unit. I'm going to save it. In web action items, I'm going to add another one, and that will be the web action item put. And that will be key value put. The path info will be key value star, but the meta type will be put. So the get request will go here, and the put request will go there. And the put request itself, I'm going to copy that over again from the completed source code, because you don't really have the time to actually code this manually here. You can do the same, obviously. So in the events here, in the on action, I'm going to add the same code that I added here for the get action, and then copy it over from the completed code. So the code here, which is the put, let's go and find the put. No, was it creating a put or a post? I was meaning to create a post, I think. Yeah, I was meaning to create a post. I'm sorry about that. So I'll just go back. and change the web module action item here and just change that to post. But you can do that in Delphi. It will just correct everything for you. And then if I go here, I'll just have to make sure that I save it first. It's going to remove that action item and then go back here and then recreate the action item. And now we have a post action. Little error on my side. So in the post action here, just go put in the post action. It's going to update the data. I'm going to copy that over. And again, this code is also in the article. So in the PDF, you'll see the same code. So what does the post action do? It will use the same get parameters to get the /1 and /value. So the /key and /value. And the key will be the first parameter and the value will be the second parameter. So if there is a value, that's going to be the second parameter. If you're sending the data not in the URL segment, but you send the data in the body, you'll use the request content. And if the value is indeed not empty, you'll respond with a result that it all worked out and that the request is actually handled. Okay. Let's also add the put action because we need that as well. So the put action, go here and add a web action item, which is a key value put. Path info again is key value. Do not forget the star, because otherwise you would not be able to use URL segments. This one's going for put and on action, and copy the on action over from the source code provided. So this is the get, this is the post, this is the put. Alternatively, you could also just open the completed version of the source code. That obviously works as well. Copy that over. And if you look at the put and the post, you'll notice that the code is pretty similar. This is one reason why some web services only have a post action and don't have a put action. Because there's no reason why you shouldn't use post to actually insert data, update data, or replace data as well. It all depends on how you want to store your data. You can do both. And again, it's also using the request content. Okay, so I'm just going to save that. I'm going to run it. And then test it using the REST debugger. Start the web service here, and then go to Tools, and then go to REST debugger. And in the REST debugger, just going to make sure that it runs localhost port 8080, key value. And the one that's added as default is key value 0. Yep, that's still there. Then we're going to put a value in there. And that will be 1, and then /1. And send that request. This is the result, so it actually worked. Now get that data. And you get back 1. If you run a second service client, this project cannot be compiled when the other one's running. Oh, I've started it as in a debug mode. That's fine. You could just run it from here as well. So now just go here, show in Explorer, Win32. I haven't built it. Oh yeah, I have. In the client. Just run that. Go to key value. and request a value of 1. And we get 1. And you can use this web service from multiple locations. So you could use it from your tablet, from your phone, and you can store arbitrary data in it, because just one is, well, just one, but you can put other data in there as well. More complicated data you would add with the put and then use number 2 here, and content type application JSON, and just add it to the body. Exclamation mark, send. And then if you get the data, let's use the client here and go to key value /2, just add it to the body. That will allow you to add some code that wouldn't fit in the URL segment because of the spaces and the exclamation mark. Okay, so let's take a look at the question panel, how far we are. Let me see here. Oh, great. Oh, yes, this works. And that's fine. And could you show an example how to extract parameters with request.content in the case of sending a body content? Actually, I think I just did that. So the request, the response.content, as well as the body itself. So the request content. It doesn't really matter how you use that request content. So you could put additional stuff in the request content just apart from the value. So here I'm just using it as a value container, but you could actually add parameters to that content as well, because the content is just a string. So you could parse the content as a string and then have parameters and values in there as well. That would deviate from the default usage in representational state transfer. So it would be a different way of using it. Not less valid. I mean, you could just do that. I mean, REST is pretty loosely defined. It's perfectly fine to use the content for both parameters as well as content. It's just non-default. That's it. That's all. Okay, so I'll post that. Go back to here, post, as well as put. Those are the two that we created so far, where we used an add or set value in the dictionary to actually update the value or insert it. So you could replace the existing resource or insert it. And we need to add the delete as well. The delete would just remove the key from the dictionary. The code itself, pretty straightforward. So we're going to add that. The delete here is somewhere up here, I think. Yeah, it's simpler code even. So just going to copy that and add that to the web server. There you go. To the web action item, add another key value. Web action item, that will be key value delete with the delete method and the path key value star for the uniform resource identifier. And in the action, it's going to delete the item. Get the parameters from the URL, set the response type, remove the key, and then set the response content, set handle to true, and it will delete the value. Let's test this out before we modify the client, because we have to code some stuff in the client as well. Go start, open the browser, software calls connection abort. You'll see this at some point. The reason for that is because the browser is now resetting the connection and it was already open. the browser was already open. So what I need to do is actually close the browser, because the browser thinks it's reconnecting to the same web service, but it's actually a different web service. It'll get a different identifier and it'll get confused. So what I need to do is just close the browser, rerun the web service, start it, and then open the browser. And then it'll just run just fine. Okay, so slash key value /0. That still works. I'm going to use the REST debugger to put a new item in there. I'm going to use the segment here to put that in there. Then I can request that with the browser. It's there, number one. Then I'm going to delete it. And then I'm going to request it with the browser. It's still there. And it's not. The item's not found. So now we've gone full circle. We put data in there. We've deleted it. We can also update and post it, obviously. Okay. Next up is the client. Let's make a small modification to the client code where we'll be adding a the get or the put. Actually, we can do that next time because I see that the time is running short already. So we only have 13 minutes left. Let me see here. So let's take a look at the questions. Let's go back to the HTTP delete REST mapping here. I'll just put that on screen. So this is what we created so far, and I'll go to the questions.
There are a few questions here about what are the differences between web broker, data snap, RAD server, etc. I tried to summarize it, but if you want to explain that more, that would probably be helpful.
Oh yeah, sure. Well, actually, web broker is the base level, most simple thing you can create for a web server or web service. It's built into, it's just a base level thin layer over in the HTTP server or over a IIS information server or over an Apache server. And it responds to HTTP requests and it allows you to handle those HTTP requests. So it's very basic. The RAD server is a more elaborate construction that's also based on WebBroker, partially based on WebBroker, I should say. And RAD server already has a lot of the REST endpoints that we're defining manually now in our code. And the REST endpoints are easy to add as well. It also includes a database backend with Interbase, so it allows you to persist the data. RAD server is something that you can actually license from Embarcadero and just install, and then you wouldn't have to write your own web service, but you would have a lot of capabilities that you also have with the base level web broker already made. And the third one would be the, let me see here, sort of lost it. Third option.
Data snap, web broker, and RAD server.
Yeah, sorry, data snap. Yeah, and data snap is just the next. Data snap would allow you to use web broker to service data from a database as tables. And if you change some data in that table that you display in your user interface, you can just post the changes back to the data snap server, and you don't have to write anything REST related if you don't want to. The data snap would allow you to just interface to your database in a way that resembles client server, but it's actually using multi-tier. So it's using a client, a server, and a database server. But it's also based on WebBroker, and it also uses REST requests. So you could just sit in the middle and see the REST request where you get data from a table, and then the table data is returned. And that table data, if you change something, only the changes will be posted to the DataSnap server. DataSnap is actually a pretty nifty solution. It's very handy to use. I'm not sure if I'm explaining this correctly, but
I think so. I mean, realistically, you can accomplish the same thing with all three. It's just that they kind of effectively build on each other. Like you said, web broker is the lowest level minimal. I mean, you could technically do everything you're doing with just the server sockets components, but web broker adds a little bit on top of that. And so it's just, you're building up the stack. It goes web broker at the bottom, data snap is kind of the next level that adds the concept of data sets and change sets and stuff like that. And then rad server adds user management and endpoint management and stuff like that on top of that. So you can accomplish everything with all three levels, but it just kind of depends on where you want to start at.
Yeah, I think I like that explanation even better. I think that's a very good explanation, Jim.
Oh, thank you.
Going up the stack, yeah, that's very clear. To me, it is.
Have you done any benchmarking? And I know benchmarking is always tricky, but benchmarking between a Delphi REST server versus a React or JavaScript-based web server?
Actually, I have. And it really depends on your hardware and network infrastructure as well. So I've seen response times for a REST request to a web broker that was handled within 1 or 2 milliseconds. So you do a GET request and you get the request back in 1 or 2 milliseconds. But that's not with the standalone option that I'm using here. The standalone option that I'm using here is using an indie server. In order to get to the 1 to 2 millisecond response times, you actually have to deploy it either to Apache or Internet Information Server, because that's faster.
Yeah, that running it on IIS or Apache gives it the ability to run. They hook the socket at a lower level in the OS, which gives it better performance.
Yeah,
so that's a really important point.
Yeah, it is, and it's already preloaded in memory. You have to make sure that every object that you're using is already preloaded. So you have to optimize a bit, but it's not that hard to get response times between 1 to 3 milliseconds. If you're using React or JavaScript, you get similar response times. I must say that the React framework allows you to do services that are, I think, they can scale up a bit more on a single server. Web broker tends to bottom out at about 1,000. Let's say 250 per CPU. I think React is just a little bit more, but not that much more. And if you want to make better use of your hardware, you should probably look at MoreMod, because that's somewhat faster. But to be honest, I tend to prefer WebBroker because it's very easy to use. It's very straightforward, very flexible. You can do things that you couldn't do in React with WebBroker. The application content type, for instance, I'm returning the application content type here in the code. So stop that and just show you what I mean here. So I'm returning application JSON here, but it could also return something else, like a PDF or HTML. And stuff like that's quite easy to do with WebBroker. And you can combine it with the Izapi native functionality for returning HTML. Basically, you've got a lot of freedom with WebBroker, and that's something I like. I like using that as well. So in performance, it's similar, and there are faster frameworks out there, but mostly it's WebBroker is fast enough. Okay. Why? Sorry.
Are you going to get into more details on looking at head and options methods?
I am not going to use them, but I can actually explain a bit about them. Especially head can be useful, and options actually used further on, but it's used in a way that you don't actually see it. So if you go to HTTP commands, let's go up here, because I've got a complete list somewhere up here, I think. No, I thought I had a complete list of the, yeah, actually I don't. Go here though. So there's the head and the options. Head is actually like a GET request, but it doesn't actually request the data. So you can see here, head is identical to GET, but the server must not return a message body. So head is actually faster, and head would allow you to determine whether or not a server is available and whether or not it could do a GET request. And the response should be identical to the information sent in response to a GET request. So head is a fast heads up, actually, something like that. Whereas the options allows you to determine what kind of possibilities the web service supports. And I'm going to use options later on. I think options somewhere over here. Yeah, options. I'm going to use options later on when I ask the client not to cache any data. And options is actually used in a transient manner there. I'm not creating a web method that has options. I'm just responding that I support the GET request, and I'm requesting it not to use caching. And I'm using that in the before dispatch handler of the web broker. But I'm doing that, I think, day 3 or day 4. I'm not sure. That's either tomorrow or the day after.
And are you going to get into extract params with request content for sending body content as well?
Actually, I did send body content here.
Okay.
So I did. Maybe I wasn't clear on that. But the web module unit here, if you do a get here, you see here, post get action, yeah. The spawns content is actually sent in the body, and the put and the post, the put here, it can send a value in the parameters, but you can also send a value as a body. And this is actually the body. So, like body. And I'm going to change the client to actually use the body for sending, and I'm going to do that tomorrow because the time's running out today. So tomorrow I'll expand on the client and make sure that it has the put, the post, and the delete, and I'll be using a stream to actually fill the body with content. And that would allow you to send a PDF file, for instance, to your web service if you wanted to.
All right, there's a couple people commenting about how great this is and very useful. One more question here: is it possible to retrieve remote user information authenticated within Apache or IIS?
Actually, not in the community edition because the component's not there. But if you have the professional edition, you can just add basic authentication to your web broker. And that basic authentication communicates with the IIS authentication mechanism, and it's actually using the authentication mechanism that's built into the Internet Information Service. So in a way, yes, you would be able to communicate with IIS for basic authentication. But usually you'll end up using something like OAuth, because that's more flexible. You don't really want to store passwords on your own web server, especially since there are a lot of breaches and security lately. And making sure that your web server is up to snuff and very secure is a hard thing to do. And using OAuth sort of lets someone else take care of that. So that's probably a safer solution.
I think that's really good advice, actually, because it is storing passwords correctly is complicated. There shouldn't be any technical feature differences between professional and community edition. So I'm interested that you said that that's missing from community edition, because I would expect that to be there.
Okay, yeah. Actually, I was looking into the feature matrix this morning, and I saw in the feature matrix that it said it was missing. So I was just assuming that it was. Because I don't have the community edition running at the moment. I'm using an enterprise edition. But if I go to the WebBroker Data Snap multi-tier thingy here, and you go to authentication somewhere over here, authentication somewhere over here. And I think it was missing, but here, authentication and role-based authorization. Yeah. So,
so that's an enterprise, not, okay. Yeah, that's an enterprise, not professional.
Yeah. And it's just a basic component. I mean, it's quite easy to create that functionality yourself, but it's probably cheaper to just buy enterprise. But yeah, that's just me. I mean,
yeah, exactly. And that's the thing, really, is that really everything in Delphi is written in Delphi. So
yeah, it is.
You could implement it all yourself, but it's usually cheaper and easier and better to buy it from a third party or from Embarcadero.
Yeah, because then you don't have to maintain it, and you're sure it works.
Exactly.
Yeah. Yep. Yeah, I had a professor in the university, and he had a quote. He said, "Software is the art of creating bugs."
That is so true.
And it is kind of true, yeah. It is.
There is a actual metric in project management around lines of code equating to bugs created, and that you have to have, based on how many changes of lines you have, determines how much time you have to spend in debugging that and beta testing it and stuff.
Yeah, I think it's exponential, but
yep.
Does it actually give you an estimate that you can complete within the lifetime of the universe, or?
So the general best practice is you have to create estimates based on past performance of a team and stuff like that. It's interesting stuff, but there's quite a bit of science that goes into estimating all of that.
Yeah.
All right.
Yeah.
I think I've got all the questions here. I do have to go. I have another meeting that's starting. I apologize.
No, it's top of the hour, 6 o'clock, so we should be stopping. If you have any questions, tomorrow I'll be back at the same time and the day after as well. So just pop over and ask them again. Just work out fine, but I think we've got all questions covered.
Yeah, and then I will also extract the question log so you can go through it, and we'll try and post it with the replays as well, which the replays will be on the blog post, which I've posted links to.
Yeah.
But if you go to the main summer camp page, you'll find links to the days and Danny's session as well. So, all right, thank you so much, Danny. I appreciate it. This has been a really great session. Lots of good stuff.
Yeah, it is, and thank you too, Jim, for helping out. It has been great. Thank you, and everyone for attending. Hopefully, we'll see you again tomorrow. Okay.
All right. Take care. We'll see you all around. Later. Bye.
See you. Bye.